Hi there, I can help with your refund. Could you share your order number?
Yeah, it's order number 1001. Hello? Did you hear me? Hello?
Thanks for waiting. I've processed your refund for order 1001, and you'll receive the confirmation shortly.
Glad I didn't hang up. Okay, so that was a voice agent processing a refund. The customer asks, the agent calls a tool, and the tool hits an order system that takes about 14 seconds to answer. And for all 14 seconds, the agent says nothing. No, give me a second. No progress, nothing. And that's how you lose a call. The customer figures that the call dropped and hangs up before the refund even finishes. Now watch the exact same agent, same slow backend, but do it right.
Hi there, I can help with a refund. What's your order number?
1001.
I've started your refund for order 1001. It's in progress now, almost there. The refund amount is confirmed, and I'm sending it through the payment processor now, almost there. Your refund is complete, and the confirmation number is RF-1001.
Amazing. Thank you. That was easy. So there you saw the same thing, the same 14-second backend. I asked for a refund, and right away the agent started giving me progress updates. Starting the refund. This will take a second. No dead air. And then it keeps on posting me about the progress as it goes. So it was the same amount of time waiting, but a completely different call. The customer never wondered if the line dropped because the agent never went quiet. And that's async tools. The gap between the two versions that you heard is basically one line of code. So let me show you how it works. So here's why the first one was so bad. When your LLM decides to call a function tool, the runtime awaits that tool and only lets the agent speak once it returns. So for a tool that's fast, you'll never notice, but this one awaits a verify order, 6 seconds, then issue refund, 8 more seconds. And so while those awaits run, the agent's turn is blocked. It can't speak. It can't send progress. It can't be canceled. But async isn't a special kind of tool. An ordinary function tool is synchronous right up until the moment that it calls ctx.update. This one never does that, so it just sits there. This is the entire fix. It really is just one line. Inside of your tool, you call await ctx.update with a message. That first call hands control back to the LLM immediately and uses your message as the tool's return value for now, and marks the call non-blocking. So the agent voices starting the refund while the tool keeps running in the background. Now, the first CTX update is the seam between a blocking tool and an async one. Everything after it is just more of the same. When verified order comes back, a second CTX update tells the customer that it checks out and you're sending it through. And then the final return is the line that says that it's actually done. Now you can also add filler updates. So where CTX update adds status for the LLM to voice, with filler plays a short line straight through the session during a quiet pause. So even gaps between updates never go silent. Reach for CTX update first and then sprinkle fillers over the waits. Now at some point you'll run into a user that wants to stop or cancel a tool call in progress. Now you can opt a tool in with the cancelable flag. And once any tool is cancelable, the framework auto exposes 2 more tools to the LLM for you, the get running task and cancel task. Now you don't have to write those. And so when the user says stop, the model calls cancel task. And that raises a cancel error inside your running tool. Now cancellation is opt-in on purpose because most writes are not safe to stop halfway. A refund is a perfect example. The backend splits this into 2 phases. Verify order is just a read, so canceling there is totally fine. There's no money movement yet. But issue refund is the write, and so you do not want to cancel that in the middle of it running. Now, one more distinction is that interrupting is not canceling. If a user talks over the agent, you throw away the tool's results, but the code keeps running in the background. To actually stop the work, you need cancelable plus the cancel task. Now, LLMs will sometimes call the same tool twice before the first one even comes back, especially when a long-running tool hasn't reported in yet. Now, for a refund, a duplicate is double the money back, which is great for the user, but not so great for business. So on duplicate decides what happens, and duplicates are matched by tool name only, not the arguments. So there are 4 modes: allow, which is the default, and it just allows both to run. Reject turns the duplicate down and tells the model to cancel the running one instead of starting a second. And then replace cancels the in-flight call and starts over, which needs the tool to be cancelable or it will error. And confirm bounces it back to the model to ask again. For money, this is easy. The refund tool uses reject. Now, one more thing, if your agents hand off to each other, by default, an async tool belongs to its agent, and any pending updates get dropped when you hand off. So if you need the tool and its updates to survive the handoff, maybe the refund keeps going while control moves to a billing specialist, you wrap that in an async tool set and pass that to the session. Now, async tools takes the slowest part of a voice call and turns it into a conversation. The agent acknowledges right away, narrates the work, stops when you ask, and won't refund the same order twice. Links to the docs, the architecture guide, and a way to deploy this on LiveKit Cloud are all in the description. Give it a try, tell us what you're building, and if this video was helpful, give it a like and subscribe for more voice AI content like this.